All right. Hello, everyone. My name is Ankita, and I'm a tech educator. I'm going to be talking about how I architected and scaled a production ready modern course platform with Next.js. I want to walk you through what it takes to scale a serious platform as a one person business, the architectural choices I had to make, the mistakes I made along the way, and some performance wins that made it all possible. Now, the lessons and learning that I'm going to be sharing here will be applicable to any content heavy platform that you would be working on. So, having said that, let's dive in. So, this is the course where I build the course platform if you want to go check it out. So, the first question is, why did I build a custom course platform? Because developers learn best by building, not just watching. Existing course platforms were static. Most online coding platforms are not meant for developers. We need to experience things. We need to experiment, break things, and see results instantly. And watching someone else code isn't enough with just video tutorials. You need to touch the code yourself. But, as every developer does, I can sort of go overboard. So I wanted to add some constraints here. My goals were quite simple. No, build a platform for developers. No cookie cutter platforms, no just text and video, or just simply text. I wanted interactive lessons and live projects. And I wanted the users of my platform, that is my students, to learn by building and doing. I also wanted to make learning more fun, so which will help improve retention. So I wanted to add some gamification features as well. So first, let me talk about the tech stack, and this tech stack blends Next.js's modern features with reliable tooling. So obviously, the first one is Next.js. The foundation of the platform starts here. For its full stack capabilities, I use React for interactivity, which Next.js is built on top of, and TypeScript for safety at scale. Then on the back end, I use NeonDB for my Postgres database. It's serverless, scalable, and instantly connects from anywhere. On top of that, I also use Zod, which ensures every request, schema, and form is validated before it even hits the database. So no unsafe data, no surprises. I used MDX because every lesson is written in MDX, which lets me blend Markdown with live React components. This, combined with server actions, meant that students can interact directly with the lessons. For the embeddables, for coding in environment embeddables, I use StackBlitz, and StackBlitz is an amazing platform where I could spin up a coding environment and go from there. Tailwind CSS that handles the styling. Shatsy and UI gave me a solid component foundation, and together they made the platform more accessible and modern while keeping my CSS lightweight and consistent. I use Sentry for logging, so I know exactly what's going on with my app, and Vercel handled all the deployment and edge performance, perfect for a global learning audience. Having said that, now that have a good understanding of my tech stack, let me talk about some of the learnings and lessons along the way. So these were sort of the basics that I wanted to follow. These metrics shaped every single choice I made in the app. How stable the layout feels when loading with cumulative layout shift, largest contentful pane, how quickly the main content appears on the screen, how fast your UI reacts after a user interaction with INP, and how quickly the server starts responding with time to first byte. These metrics also help me build trust with my users as I focus more on them. So architecture. Once I knew that performance was my North Star, the next question was, how do I architect it? Because architecture sort of decides everything, how the data flows, how quickly it responds, and how easy it is to scale later. So this is how I built the platform, and it's actually aligned with what we heard today at the keynote. I use React Server components. So I fetch data close to the source, which made it seamless for me to handle any reads. Server actions handled all the mutations, so I could mutate data securely. It also cut client-side JavaScript drastically and dramatically, boosting my INP and no more loading spinners everywhere. I used the Next.js app router that allowed me to organize my layouts and routes, and there is a lesson in layout that I will share shortly. But my model was simple. The platform is server first and cache first. I don't use any state management library, even though this is a massive platform. Data lives on the server, client-side JavaScript only where needed. Let me show you all a visual here. So this is how it works. Performance starts directly on the server. I would render close to the data for instant responses. I would repurpose that data with cache and hydrate only when necessary. This allowed me to cache smart and hydrate light. It allowed me to keep my app snappy and lightweight, minimal JavaScript, maximum performance. And truth be told, not every single component needs JavaScript from the get-go. So I wanted to reuse data efficiently and ship minimal JavaScript. But like I said earlier, my goal was also to make the course platform interactive. What that meant is I wanted static lessons, for example, over here, and interactivity, as you can see in this specific demo. So my students can just type in and guess what components I'm using in this interactive demo over here. But this meant I had to use MDX, which I talked about earlier, with React, which allowed me the ability for providing interactive learning and provide interactive React components. So that's how I can teach a concept, show live code, and let students experiment instantly. All is inside one single MDX file. But here's the truth. You'll be learning to build 7 production-ready applications. And what this means when I'm talking about 7 applications, it means there are going to be lots and lots of lessons. So my platform has 450 lessons in it right now, which means there are 450 MDX files, each pre-rendered, cached, and streamed intelligently. At that scale, performance can be optional. It becomes a product itself, which is why performance cannot be an afterthought here. So every lesson in the platform, this is how it looked like. The platform is sort of divided into multiple data-heavy parts. I have drawn these borders around it so you could see. For example, this is the curriculum. This is the lesson header, the lesson content itself, and course progress, and also the learning progress. Now, each of these fetched data separately, which cause redundant network calls and higher time to first byte. And that is where layout optimization came in play. Move the heavy data to layouts. Now, instead of fetching data in every single component, I preloaded shared data inside the layout file. That one shift reduced my time to first byte drastically because layouts stay mounted while pages underneath changed. But here's a mistake that a lot of us make with layouts. They aren't just visual, they are in fact data boundaries. They're not just wrappers around your components. You could actually load shared data like navigation, user progress, analytics, keeping it stable across routes. This change alone made the navigation feel instant and predictable. For example, over here, if you can see, curriculum is what I moved to layouts, course progress, and learning progress as well. And this UX transformed without adding any new libraries, just a smarter architecture by moving things up a little bit. So we need to start treating layouts as persistent data shells. They're not just for styling or structure, they become a foundation for every single app. So going back to Core Web Vitals, it improved my CLS, LCP, and time to first byte. So servers started to respond much faster as I'm keeping my caching separate. It's proved that architecture changes directly shape performance metrics, and I immediately saw a drastic difference here. Next was data fetching. This is where you win or lose performance, and it's not something you could, sort of revisit later on. It is one of the hardest and most impactful decisions in building my platform. This was my thought process. Full SSR would be too slow because I'll be loading every single MDX file. That can happen. Full SSG was too stale. I wanted a strategy that would work. So for landing pages or marketing content, I used static site generation. It was perfect for SEO. I could rebuild only when the content changes. and it's ideal for any stable marketing pages, which is awesome. However, for dynamic lessons, I needed to be a bit more strategic here. Not every piece of data deserves the same treatment. Static data, I wanted to use static site generation. Dynamic data, I wanted to use SSR or server actions. Shared data, I wanted to cache once and reuse. And I wanted to balance my speed as well as freshness. And that's where, you guessed it, if you know what I'm talking about when it comes to data fetching, it is partial pre-rendering. That became my sweet spot. I did upgrade early. It gave me a static shell that loads instantly, which is great for my largest contentful pane, and then stream in the dynamic sections like progress, analytics, and so on. As you can see, skeletons filled the gap here, layouts didn't shift, and the static shell streamed data as it's ready. That's what makes partial pre-rendering feel instant. So I added suspense boundaries everywhere, and you can think of them as little suspense islands. Skeletons would fill the gap. Again, improved my CLS because layouts don't shift now. They give a static shell for perfect CLS. And the largest contentful pane also streamed the shell, which led to high responsiveness. And the conclusion here was speed and freshness can coexist when you can stream data. This is how I was able to achieve both fast LCP and low time to first byte. The next word is caching. We talked a lot about it in the keynote today, but this was truly one of the reasons why my platform felt instant. The secret to instant navigation and predictable performance. So this was one of the challenges. I needed metadata for search engine optimization, such as lesson content, but I also needed the same data on the page because I wanted to provide that same data to search engines, but I also wanted to show that to my users so they could access it, which means I wanted to keep one source of truth for lesson data. The generate metadata function from Next.js allows us to, create the search engine optimized content for lesson pages, but also the page needed it too. So what I did was I cached this shared lesson data so both could reuse it. So the idea here was before caching, I was fetching it twice per page load, which is massive. But after caching, I was able to cache once, which led to smoother navigation and consistent SEO metadata. Here's what that looked like. I cached the metadata. I'm using the React cache function. However, you could replace that with the cache from Next.js as well. It's pretty much the same. But this meant both of these now can access the same cached content, and I repurpose the same function everywhere where I needed lesson data. So we wanted cache functions that are expensive, but not everything needs caching because that could also slow down performance. So you need to be more intentional about it. Now let's talk about one button that I thought that I never have to think about before building this platform, but I did spend quite a lot of time here. Certain actions in the platform took way longer. For example, it is the mysterious mark as complete button in the platform. It triggered multiple backend updates and cache invalidations. It looks simple, but it isn't. Initially, this specific function took about 16 seconds at first, which is honestly just bonkers to me because at that point, I'm going to leave even my platform. It killed perceived interactivity and my INP went red. But if you think about it, even this simple function was doing a lot. It was checking if the user is a student. It was adding some completion status to the table because as the student marks that specific lesson as completed, it awarded some experience points because, again, I want to make it fun. I want to gamify it. It also cleared the global cache for the page, and then we navigated to the next lesson. And if you take a look at this meant that every single time a student pressed that button, all these database calls were being made. And yes, I did use server components and all, server actions and everything that I talked about. However, I still had to optimize it further. Now, this specific function here, clearing the global cache, I didn't need to do that. Like, this was something I could delegate it or run it in the background, which was another lesson in the platform is to avoid global cache bursts and instead use tag-based validation. Instead of clearing the global cache every single time a student presses the lesson as completed, I decided to only tag a cache and then delete the cache, invalidate it. So when a lesson was completed, I only revalidated that specific tag, keeping everything else cached. Because not every student is going to go through 450 lessons at the same time. So revalidation path was the function I used to clear the global cache for that specific route, which was too broad. It refreshed entire routes. We are going to now switch that to revalidate tag. And here's how that looks like in practice. I tag the cache. So as you can see, I'm caching the fetch. This is just getting the experience points, and I'm tagging the cache right there with the tags array. And then I'm using revalidate tag function, and this is the code inside the button mark as complete lesson. This is part of the code where I'm busting only the tagged cache, not the entire page. And this precision caching really beats global invalidation every single time. Now it's down to 10 seconds, which is awesome. But still, 10 seconds is pretty bad. So who here has ever clicked a button and waited and wondered if it ever worked? Well, that's exactly the experience my users had. Even though the backend felt faster, it felt slow because the UI didn't respond right away. So let's go back to the function here and let's talk about awarding experience points. Now, why should we let the user wait for awarding experience points? And that is where another function from Next.js, which is sort of underrated right now, with after, it allows you to run your code after a response has been sent, but in the background. This is how it looked like. For example, on the left-hand side, we have this specific demo where before after, it's going to run all those functions and it will take user 3.5 seconds. But with after, if you wrap the code that's going to take a long time, like background tasks, like awarding experience points, you could wrap that with after. And here's how that looked like. Now, I wrapped it with after, and now it wraps my async logic, letting the response return immediately. Again, it decoupled the UI from heavy lifting, making the app feel responsive again. Drop to 6 seconds now. We are getting there. But this was great, but we can do better because it's not just about numbers, but it's about perception. Users shouldn't have to wait if they don't have to. They shouldn't wait if they don't have to. And most actions succeed 99% of the time. So why are we making them wait again? And that is where I want to introduce you all to optimistic UI. Perceived speed is what I focused on, while letting the server handle whatever request it can. So again, you know, marking the lesson as completed, showing this confetti, which will show up. And I wrap this specific button change in a code called as use optimistic. With use optimistic, I maintain a local state that immediately reflects the expected change. Once the server confirms, I merge and correct the result. And this specific change itself really made my app feel fast, my action feel faster. So with optimistic UI, now clicks feel instant because I immediately reflect completion. I improve the interaction to next pane because now there's lower INP. And then perceived speed means it feels instant, which is the ultimate goal for performance. It feels fast, not just is fast. And lastly, no one likes a frozen screen. And your app can be technically fast, but if it locks the user out while fetching or submitting data, it can feel broken. Let's take an analogy. Imagine you're at a restaurant and you order food. Your server comes to take your order there, and you are not allowed to do anything. You're not allowed to chat with your friends or do anything whatsoever. Basically, you are frozen, and that is the reality in our browser. We need to keep the conversation going. We need to show something. So when React introduced concurrent rendering, use transition became one of my favorite hooks. It lets you separate urgent updates from the non-urgent ones. So we can say, instead of freezing this UI, while React tries to figure things out, use transition says, hey, this update isn't urgent. Let's keep the app responsive. And I wrapped my code around the start transition with also optimistic UI that directly improved my interaction to Next Paint because now the browser never blocks user input. So now perceived time dropped to 1 to 2 seconds. I'm being generous here, it's less than that, but that truly helped shape the performance of my application. So again, I directly impacted core web vitals, which were my North Star. After optimizing layouts, we saw the impact immediately. Moving shared data to layout cut redundant fetches, meaning service started responding much faster. It boosted largest contentful paint since content could render sooner and improved my cumulative layout shift because the layout stayed stable while the data got streamed in. It is proof that architecture changes directly how the performance metrics. And the other part I want to talk about is how AI accelerated my workflow. Because AI really personalized the learning experience I wanted to provide, but it sort of became, I used it as a learning coach for adaptive quizzes or giving instant code feedback to my students. And for that, I use the AI SDK, which is incredible. And I have these mini agents helping me with a bunch of tasks in my course platform, but also use Cursor to spin up that AI agent to bake intelligence directly into the user experience that I wanted. So if a student asks me a question, depending on the task, I have an AI agent tool spun up to do so. We are short of time, otherwise I would show you the code more so, but that could be a separate talk altogether. And lastly, I want to talk about the dopamine effect. While everything feels instant, something magical happens. The brain releases dopamine. And that's exactly what I wanted to provide in this course platform as well. So I added beautiful animations across my course platform, but with very simple code. And this is one of the apps that you will build in the course. But as you can see, this pulse animation lets the user know that something is loading. So code like this gave me the permission to add the data pending attribute, which indicated the pending state of the component. And with Tailwind Animate Pulse, I basically pulsed the specific section of the code. And again, it improved perceived speed and the app felt instant, which is exactly what I wanted. But one of my goals after all of this, as part of all of this, is that I want my learning to be accessible. I want to have a global reach. So there are plenty of free lessons on my platform because I truly believe that whoever is getting started with Next.js should be able to just go to my course and get started and learn what they need. And there are so this is why I added purchase power parity pricing, a system that automatically adjusts based on where the learner is, and it ensures that the price is fair relative to the economy of the country and so on, and it creates a more fairer system for learning online. For that, I used a tool called paritykit.com, which gives you fair pricing. And this is the banner that you will see on my platform, which is a embeddable script in my platform that I use the script component for from Next.js. But again, as I combined this, it made the learning accessible. But after all of this, the real impact wasn't just speed metrics, because my users are not necessarily going to care about all these different metrics. What they're going to care about, what I'm going to care about, is engagement, which means happier students. Faster apps means longer learning streaks. Faster app also means happier learners because performance improves retention. If your app feels smooth and rewarding, people feel motivated to keep going, and that's what build, scale, teach really means to me. It's not just about chasing metrics, it's about creating impact, and that's the mindset I want to leave you with. First of all, you got this with AI. I feel like at our doorstep, I think the learning has been really accessible. But you don't need a team, you just need a plan. If I can build it, so can you. And your story can truly start today if you want it, if there's an app that you want to ship, using all the different learnings and applying that in your app. Real impact wasn't just speed metrics, it was happier students and architect for performance and deliver for people. So if I can build it, so can you. And if you want to go deeper into what I've shown today, then you can check out nextjscourse.dev. You may come across a lot of the lessons that I talked about because now you'll be more intentional in terms of what I shared with you. So thank you so much for coming to my talk.